and I'm an avionics reliability engineer here at SpaceX, and I'm at the Cameron County Amphitheater, where a growing number of SpaceX employees are gathering to watch what we hope is the first liftoff of a fully integrated Starship. Now, the Starship team has worked incredibly hard for today's launch test. Over the past weekend, teams held a launch readiness review, which included a comprehensive review of all of our vehicle systems, looking at avionics, GNC, communications, software, structures, as well as our Raptor engines and propulsion in general. Now, we are only about 5 miles away from the launch pad, so it's a pretty good view for today. And as we get into as we start to approach T-0, everyone here is clearly very excited for the events that are happening today. So as we get closer to T-0, I'm going to throw it back to Hawthorne to talk more about a rocket.
Awesome. Thanks so much, Zach. And we've actually got a little bit of a crowd forming behind us, too. Now, we've got a shot of Starship on the screen. The entire Starship structure you see is made of stainless steel. And when that's fully stacked, it stands about 120 meters tall and about 9 meters around. To help you give a sense of just how big that is, we've captured a video of some of our teams doing final integration prep work in advance of today's test flight.
Just like Falcon 9, Starship has 2 stages, which we will talk a little bit more about in a minute. But in addition to those 2 stages, Starship actually has a 3rd stage called Stage 0. It consists of all the launch pad infrastructure built around the rocket. You can see a great view of it there on your screen. It's truly an engineering feat in its own right.
And I feel like it's something we don't talk about very often. There's a lot of infrastructure that goes into fueling and preparing the launch vehicle before a large test like this, really any launch. Now, let's talk about Super Heavy. The name says it all. It's super, it's heavy, it's super heavy. It goes by some other names, the first stage or the booster, but whatever you call it, the Super Heavy will be the vehicle responsible for powering Starship against that mighty gravitational pull we've got here on Earth. And when it's fully operational, it's going to get Starship to orbit.
The booster alone stands about 70 meters tall and is about the same height as a fully integrated Falcon 9, but with a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines.
Yeah, and having those engines, and oh my gosh, I love this shot. We can see looking up into the launch mount at the 33 engines on the booster. Those are each of the Raptor engines that's going to power today's launch attempt.
Yeah, this is an incredible view. One of my favorite views that we're going to get today. We don't have this kind of view on our Falcon 9 launches, so this is so exciting to see. You can even make out the paint markers indicating which engine is which. Like we said, there are 33 of them. So there's a lot of fire that's going to be coming out from those engines in just over 31 minutes from now. As we mentioned before, there are 33 of them on the Super Heavy, the booster, and we don't see it right now, but the cluster in the center are the ones that are actually going to gimbal and help steer the booster back down for its water landing in the Gulf.
Yeah, and they're a little bit different, Kate, than our Falcon engines. So on Falcon, we use a gas generator cycle. Here's a fantastic shot, actually, at the inner stage, so we can see the 6 engines that are on the ship side, 3 gimbaling in the middle, and then the vacuum engines. You can see 2 of them, and the other one's on the other side of the cluster in the middle here. So Raptor's a little bit different. It uses something called stage combustion, which means we basically pre-burn both the fuel side and the ox side, and then get those up to the right temperatures and pressures, and then mix them in the combustion chamber. It allows us to get higher thrust and higher efficiency on these engines than on Falcon 9. Now, Super Heavy also has 4 grid fins to assist with orienting itself during the return back to Earth, as today is the fully integrated flight test. And the first one, we're focusing on safely testing just the fundamental systems and operations on the vehicle. So what that means is we won't be attempting to land on land today. Instead, Super Heavy is going to be making that hard water landing in the Gulf.
Starship, or the spacecraft, is the 2nd stage and makes up the top portion of the vehicle. It's designed for carrying passengers and cargo between destinations on Earth, Earth orbit, and planetary destinations. It stands 50 meters tall, a little taller than the Statue of Liberty. It's comprised of 6 Raptors. We saw those just moments ago. 3 of them are optimized for sea level, and the other 3 are vacuum engines, and they're optimized to operate in the vacuum of space. They provide a maximum of 258,000 tons of thrust in vacuum. The spacecraft is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable precise landing at the intended location. You can see a view of those flaps there.
Now you can see the entire stack is vertical, and that's because Starship is designed for vertical takeoff and landing, as opposed to taking off and landing like an airplane. And that's really important because we don't have runways on the Moon and Mars. Fortunately, gravity at both of those destinations is not nearly as high as it is here on Earth. On Mars, it's about a third of what Earth's gravity is, and on the Moon, the gravity is just a sixth of what it is here. So Starship can take off in both of those cases without needing the super heavy booster like we need here on Earth. Now, for today's test, Starship does not have its landing legs attached, and that's because we aren't going to be attempting to return to the launch site or land on land. It's going to be doing another hard water landing at the end of today's test.
We can't wait. Starship is wrapped in a heat shield, which is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. The hex-shaped tiles, like these ones that we have here, roughly make up about 2/3 of the vehicle. There's a couple of different geometries. The one that I have is for the circular portions of the vehicle, so it has this curvature to it, and the one that Shiva has.
Yeah, this kind is a hexagonal shape, and there's several thousand of these all across the body of the vehicle. And it's worth saying we need these because when a spacecraft re-enters from orbital velocity, it's going faster than the speed of sound and causes a lot of heat to build up that has to get dissipated by these heat shield tiles.
Yeah, one thing that's really cool about these is they're super lightweight. Even just holding them, we're able to even just hear how hollow they are because of the construction. But they do a great job of dispersing that heat during that atmospheric reentry. We actually produce these in-house at what we like to call the SpaceX bakeries. And they're located in Texas and Florida. So it's something that we designed and build in-house. And like we said, there's thousands of them. You can kind of see them on the exterior of the vehicle. So at this point in time, we are at T-minus 27 minutes and 18 seconds. So let's head on over to John Innsbrucker for an update on the countdown. Hey, John.
Thanks, Kate, and good morning. I'm John Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Now, both vehicles use the same 2 propellants. Our fuel is liquid methane at a temperature of just over 100 kelvins, or about minus 272 degrees Fahrenheit. Now, this is a different fuel from Falcon 9, where we use RP1 kerosene. And our oxidizer is liquid oxygen, the same as Falcon 9. But because there's no oxygen in space to support combustion, we have to bring our own. Now, a little bit of a recap. We did the go, no go poll at T-minus 1 hour and 45 minutes. And once the team gave their goes, we polled about 20 folks. We started loading propellants onto the booster at T-minus 1 hour and 39 minutes. And at T-minus 1 hour and 22 minutes, we began propellant loading of the ship, the second stage on Starship. Now, LOX loading of the second stage main tank is almost complete right now, but we'll actually stretch it out and wrap it up and finish at T-minus 5 minutes. And then at T-minus 3 minutes, as the booster finishes loading, the vehicle will be fully loaded with just over 10 million pounds propellant. Now, currently in the countdown, we've just passed the T-minus 26 minute mark. The good news is weather's looking good. You can see the blue skies there on the camera views from the drone. The only thing we're watching is winds. They are within limits at ground level. We expect they may pick up a little bit as we get farther into the window should we need to go that far. But the good news right now is that the weather is looking good. The range also is looking pretty good. We've moved almost all the boats out of the keep-out zone overnight. We are working one, but we're still underway. And right now, as a reminder, if for any reason we do not make our test flight today, We have backup launch windows. This could be either 24 or 48 hours after today, and it'll depend on how far we get into the countdown. But coming up on 25 minutes to go, everything is looking good, Kate.
In order to make life multiplanetary, we need a fully reusable vehicle that's capable of carrying a huge amount of cargo and a lot of people to orbit and have a pretty quick turnaround. The idea is to effectively reuse launch vehicles just like airplanes. Crowd is getting excited here in Hawthorne behind Mission Control, as you can hear. Now, imagine if you had to wait for a new airplane to be constructed every time you wanted to fly. You'd rarely go anywhere, and it would probably be completely unaffordable for most of us. In order for us to get to Mars and back with lots of people, multiple times, reusability is a must.
Now, in the near term and a bit closer to home here on Earth, Starship will be critical to other programs as well. Once it's operational, Starship will deliver the full-size and upgraded version of our Starlink satellites. And that's super exciting because our next-generation satellites represent a step forward in Starlink's capabilities and will provide more bandwidth and increased reliability to connect millions of people around the world with high-speed internet.
And of course, Starship will fly a number of human spaceflight missions in the lead up to our first missions to Mars. Entrepreneur and pilot Jared Isaacman will command the first human spaceflight on Starship as part of the Polaris program. Jared served as a commander for Inspiration 4, the first all-civilian mission to orbit. Inspiration 4 launched aboard our Dragon spacecraft and Falcon 9 in September 2021, raising over $240 million for St. Jude Children's Research Hospital. The first human spaceflight on Starship will launch as part of the Polaris program, and you can learn more about that series of missions at polarisprogram.com.
Now, our first lunar mission around the moon aboard Starship will be led by Japanese entrepreneur Yusaku Maezawa, also known as MZ. MZ flew to space for the first time in December 2021, and he purchased all of the seats aboard Starship's first lunar mission in order to give artists and creators from all over the world the opportunity to go. And the hope is that what they will create in space will further inspire all of us here back on planet Earth. Now, over 1 million people applied for this mission, and earlier this year, they announced the final 8 crew members were selected, and you can learn more about them and MZ's mission at dearmoon.earth.
Dennis and Akiko Tito are the first 2 crew members announced to fly on Starship's second commercial spaceflight around the moon. This will be Dennis's second mission to space after becoming the first commercial astronaut to visit the International Space Station in 2001, and Akiko will be among the first women to fly around the moon on a Starship. The Titos joined the mission to contribute to SpaceX's long-term goal to advance human spaceflight and help make life multiplanetary.
SpaceX is also incredibly honored to be part of NASA's Artemis program to establish a sustainable presence on the moon to prepare for missions to Mars. Starship's early test launches, followed by those regular Starlink deployment missions and propellant transfer demonstrations, are directly advancing NASA's Artemis program, along with SpaceX's ongoing mission to make life multiplanetary.
SpaceX will conduct an uncrewed demonstration mission to the moon prior to the Artemis 3 mission, which will mark humanity's first return to the lunar surface in more than 50 years. It's an exciting future, but let's talk a little about how we got to today.
Now, Starship testing ramped up in July of 2019 with the Star Hopper prototype. It's sort of a short version of the Starship that we see today. There's a picture of it on your screen, the lovable water tower. Now, standing at just over 18 meters tall, the Star Hopper had a single engine and was test flown to perform landing and low-level altitude maneuvers. Starship's initial flight test was a hop that reached about 20 meters in altitude. This was followed by a second hop, the one that we've got on our screen, that rose to 150 meters in altitude. We took a little jaunt away from the launch pad and ended up landing about 100 meters or so further away from it, and you can see that on your screen. Now, notably, this was the first time that we had used a Raptor engine in flight and demonstrated control of this kind.
As a Star Wars fan, I can't not see a flying R2-D2 there. Now, after a series of 150-meter hop tests with earlier prototypes, the Starship program saw a huge breakthrough during a test flight of the vehicle known as serial number 8, or SN8. SN8 demonstrated a first-of-its-kind controlled aerodynamic descent and landing flip maneuver. Yes, I'm talking about the belly flop. This 12.5-kilometer hop test took place December 2020 and saw the SN8 prototype ascend to an altitude of 12.5 kilometers and conduct a belly flop maneuver. While it didn't stick the landing, the test was a major milestone in the development of Starship.
I love seeing the belly flop maneuver. Now, testing continued with the prototype on serial number 9. That was a 10-kilometer flight test in February of 2021. We had a nominal ascent, engine cutoff, reorientation, and controlled descent were stable. However, we unfortunately had a dramatic ending to the end of that flight when we had a failure on its engine to relight. That resulted in one of those rapid unscheduled disassemblies. But what was really, really exciting about both serial numbers 8 and 9 is how quickly we were able to achieve just our primary objectives in those 2 high-altitude test flights. In addition to getting lots of great data, Starship successfully demonstrated control of the vehicle and subsonic re-entry capability.
Ultimately, we performed 9 Starship high-altitude test flights in total, and in May of 2021, SN15 launched from Starbase, reached an altitude of about 10 kilometers, performed a number of maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly, control its descent, safely land, and to be recovered in one piece.
Now, having achieved that success in our suborbital campaign, one of the next big challenges for upper stage reusability is to survive the high heating hypersonic phase of entry. Combined with the ability to refill our Starship's tank with fuel and oxygen while on orbit is what will enable a fully reusable transportation system that's designed to carry both crew and cargo on these long-duration interplanetary flights, and that's ultimately what will help humanity return to the moon and travel to Mars and beyond in our solar system.
So as you can tell, it is nothing but an iterative process to get to the point that we are today and where we will go from here. That iteration is a core process of how we work here at SpaceX. We like to fly and we like to test early and often, both on the side of hardware and software.
Yeah, that's an awesome point, Kate. Now, we are continuing our countdown to Starship liftoff just over 17 minutes from now. So, of course, let's check in with John for another status update. John?
Thanks, Shiva. Clock is coming up on T-minus 17 minutes from liftoff. We're continuing to click towards 0. However, right now we've just begun listening in. The first stage team is working a pressurization issue. They're troubleshooting that right now. Now, we do have the option, if need be, if we can't solve this, then we would hold the count and probably treat today as a wet dress and not be able to launch. However, we are continuing to do propellant loading on both the Super Heavy and the ship stages. Now, most recently, we began loading liquid oxygen and methane fuel into the header tanks on Starship. At the very top, just underneath the nose there are 2 small spherical tanks. That's where the fuel and liquid oxygen header tanks are. That started at T-minus 27 minutes, and that propellant loading will continue until T-minus 9 minutes. We'll also continue loading the main tanks of the Starship second stage, although they're pretty much full right now. Everything will drain back as we get ready for launch at T-minus 5 minutes. Now, on the first stage, we're continuing to load the massive amount of propellant onto the Super Heavy booster. That's going to continue until T-minus 3 minutes. You can see the frost line on some of the views as both liquid methane and liquid oxygen go into the tank. At 16 minutes and counting, we're also currently configuring the launch pad for liftoff. The booster hold downs are being prepared for the release at liftoff, and the second stage quick disconnect is beginning its configuration for release. The liquid oxygen and methane that are going into the second stage go through that quick disconnect. You can see it in some of the views, the arm that comes out just to the base of the second stage. Now it'll move out of the way as we lift off. At the same time, the SpaceX team continues to check in with the Coast Guard. We're working one boat that's in the safety perimeter. They are working to get that boat out of the way. We cleared several other boats out overnight. We're down to one, and we expect that'll be clear so that we can proceed with launch out over the Gulf of Mexico. But as a reminder, T-minus 15 minutes, 10 seconds and counting. We are working an issue on the first stage, and we'll bring an update as we get more insight into that issue.
Now, today's test flight is taking place out of our Starbase facility in South Texas, and that facility has gone through a tremendous amount of change and growth in a really short period of time.
Yeah, I mean, 3 years ago, not much even existed there.